Hello everyone, hope you're all fine. So today I'm going to do a small talk on the topic telescopes in astronomy. We all are familiar with the word telescope. A telescope is an optical instrument designed to get magnified images of distant objects. For example, faraway galaxies, stars and planets, etc. And also it can be used to measure distance between two objects in the sky. Telescope is one of the most important tools in astronomy. Although Galileo Galilei was not the inventor of telescope, but he was one of the first person to use telescope for astronomical purposes, and his observation did revolutionize our view of the cosmos. Galileo Galilei made his first telescope in the year 1609. The telescope he used was a very primitive spyglasses. This type of telescopes is known as refracting telescope. Now let us study the working of refracting telescope. The first part of the refracting telescope is the lens. It is called the objective lens. Typically, this is a convex lens that bends light along its edges and letting the light pass through the middle unimpeded. The diameter of the objective is referred to as the aperture, denoted by uppercase letter D. Now, if you had a distant star, then all of the star's light would be coming through the lens initially in parallel. As the light refracts more at the edges, they will eventually converge to an image. The point at which it forms the image is called the focus. The distance from the objective to the focus is called the focal length. The purpose of the objective is to capture more light than the eye to produce a brighter image. Now, in order to inspect this image, we need to employ a secondary lens. This is commonly known as an eyepiece. The eyepiece lets the light rays spread apart once again and then focuses them into an image. So it basically magnifies the image and allows the eye to actually see the image produced by the objective. The eyepiece has its own focal length, and the ratio of the focal length of the objective to the focal length of the eyepiece gives us the magnification. We know that when a light passes through any medium, it will disperse into its component colors, and the same effect happens here. So when a light passes through a lens, it disperses into its component colors, but the lens can't focus all colors to the same point, as the refractive index of the lens element varies with the wavelength of light. So we won't be getting a clear and a focused image. We will be getting a blurred image as shown in the figure. This phenomena is known as chromatic aberration. So in order to fix this problem, most refractive telescopes are fitted with what are called achromatic lenses or compound lenses, as shown in the figure. These lenses reduce the effect of chromatic aberration, resulting in sharp images. Now, there are some disadvantages for refracting telescopes. One of the main one is chromatic aberration. Although this can be reduced, but when we reduce this, we introduces a new lens. The introduction of new lenses reduces the light passing through it, and also we have to build them very long for modest aperture, which results in very large structures, and lenses are very heavy and they are very expensive to produce. And this is a image of one of the refracting telescopes. Now, Newton was aware of these drawbacks and he developed an alternative method for building telescope using mirrors instead of lenses. He made his telescope in the year 1668, and these type of telescope are known as reflecting telescopes. Now let's see how a reflecting telescope works. A reflecting telescope consists of a primary concave mirror and its diameter is known as aperture. The light reflects off the primary mirror. The primary mirror allows the light to come to a focus. The distance from primary mirror to the focus is known as focal length. We can get an image at the focus, but there is a problem. If we were to place our eyes there, then the rest of our head will block out the incoming light and we won't get an image. So in order to overcome this problem, Newton set up a 45-degree mirror called a secondary mirror and redirected the light out of the telescope tubes and placed an eyepiece as shown in the figure. Now we will get a clear and a focused image as we are not blocking any light. But there are some disadvantages for Newtonian telescopes. First one is mirror with long focal length result in very long telescope, and also it can be very difficult to use as it requires eyepiece, and these instruments should be mounted at the top of the telescope. Now there is another alternative to tackle this problem. These are called Cassegrain reflector. So rather than using a 45-degree flat mirror, we use a secondary mirror which is convex in shape. This mirror redirects lights out through a small hole cut in the back of the primary mirror, so we have a more compact telescope. Now some of the advantages of reflecting telescopes over refracting telescopes are: mirrors are a lot easier to manufacture and therefore cheaper than lenses. Mirrors are a lot thinner and lighter and than lens, so it requires less stuff to hold the mirror up. And also there is no chromatic aberration in case of reflecting telescopes. Now let us take examples of some of the telescopes located on Earth. The first one is Grand Telescope. The Grand Telescopio Canarias is currently the largest and one of the most advanced optical and infrared telescopes in the world. Its primary mirror consists of 36 individual hexagonal segments that together act as a single mirror. The Grand Telescope has also a secondary mirror and a tertiary mirror that together with the primary mirror produce the telescope's focal plane. And the next one is South African Large Telescope, also known as SALT. The South African Large Telescope is largest single optical telescope in the southern hemisphere and one of the largest in the world. It has an 11-meter wide hexagonal primary mirror array comprising of 91 individual 1-meter hexagonal mirrors. South African Large Telescope can detect the light from faint or distant objects in the universe. And the next one is Gemini Observatory. The Gemini Observatory consists of twin 8.1-meter diameter optical or infrared telescopes located on two of the best observing sites in the planet. From their location, they can access the entire sky. Now these are the two telescopes of Gemini Observatory, the Gemini South and the Gemini North. And now let's move on to the telescope situated in the space. The first and the most important one is the Hubble Space Telescope. Named in honor of the trailblazing astronomer Edwin Hubble, the Hubble Telescope is a large space-based observatory which has revolutionized astronomy since its launch and deployment by Space Shuttle Discovery in 1990. Scientists have used Hubble Space Telescope to observe some of the most distant stars and galaxies. Hubble Space Telescope has made more than 1.5 million observations over its lifetime. Over 17,000 peer-reviewed science papers have been published on its discoveries, and every current astronomy textbook includes contribution from the observatory. The telescope has tracked interstellar objects as they soar through our solar system. It has watched a comet collide with Jupiter and discovered moons around Pluto. Hubble Space Telescope has peered into our universe's distant past to locations more than 13.4 billion light years from Earth, capturing galaxies merging, probing the supermassive black holes that lurk in their depths, and helping us understand the history of expanding universe. In its over 30 years of operation, Hubble Space Telescope has made observations that have captured humanity's imagination and deepened our knowledge about cosmos. Hubble Space Telescope has captured more than thousands of images, and these are the two of the images among them. First one is a eccentrically shaped galaxy called NGC 1614, and the second one is the planet Saturn during summertime. The next space telescope is the MOST, which stands for Micro Variability and Oscillation of Stars. It is the first space telescope by Canada. It was launched into space in 2003. It is a small telescope dedicated entirely to astroseismology, which is the study of star vibration called pulsations. The next one is COROT. It is the first mission capable of detecting rocky planets several times larger than Earth around nearby stars. It consists of a 30 centimeter space telescope. It was launched on 27 December 2006. And the last one is Spitzer telescope. It was launched in 2003 and its mission was ended in 2020. It is an infrared space telescope as it can peer into regions of space that are hidden from optical telescopes.